Okay, so after a quick edit, here's what happened. I did a sort of a shell game on myself, and I sort of rubbed off the letters because a dry erase marker apparently erases dry. Who knew? And I rubbed off which was which, and also the reaction is really fast, and they turned from pink to white really fast. So I lost track, and I didn't write down my times fast enough. So I just did the reaction again. If it happens to you on lab day, guess what? You just do the reaction again. In the famous words of my lab TA, my chemistry lab TA in college, that's all right. You do it over. And I am 100% spot on with his accent. I have been told by many people that is 100%. All right. Now, I had to cross out a couple of things, and this got a little wet here, so there's some crossed out. I started my 2%, my 3%, my 4%, and my 5%. All right, this was 2, 3, 4. My 2, 3, my 2, and this is 2. All right, so my 2% started at 0, and its end point was 1 minute and 54. My 3%, I started at 8 seconds, and it ended at 1 minute 40. My 4%, I started at 40 seconds, and it ended at 1 minute 22. And my 5%, I started at 51 seconds, and it ended at 1 minute and 11. So here's what happened. So as soon as I put in my step 5, I barely had any time to shake it before putting it back in, and it was almost done. So I had no time to stop the timer, and it was basically gone. So I wrote down the time as quickly as I could. By the way, these crossouts are the times that I thought I had had before, but I just ended up redoing the whole thing, so forgive the squiggles. Now, in order to do my math, here's what I do. I take my start time, and I subtract that from my end time. I have my T final and minus my T initial. So I have 1 minute and 11 seconds minus my T initial. So I have 1 minute, 11 seconds minus 0 minutes and 51 seconds. So 1 minus 1 is 0. 10 seconds minus 50 seconds is this, carry the 6 because it's time, is 7 minus 5 is 2. And that's now 0 minus 0, so that's 20 seconds remaining. So this is now 20 seconds. I do that math continuously over here, so that's 42 seconds, that's 92 seconds, that's 114 seconds. Now, the reason I'm doing that is because I'm converting everything to seconds, 1 unit, because Cambridge readings do not require you to have singular units when you report in a table. Now on this page here, process your raw data to find the time taken to reach the endpoint for each concentration. These are your processed results. When they say a processed result, they only want 1 unit. If you have time, check your results. That is code for do it again. I don't have time to do it again. You do. Or at least they think you do. So find time to do it again on the lab. Sometimes that means that there's another point in it for you, especially when your table is worth 5 points. When it's worth 5 points to you, a second reading, a second set of data is worth that additional point. A second trial is worth an additional point, especially if they prime you like that. If you have time, check your results. They mean do it again for an additional point. Just saying. 5 points for prepare the space below. If you have time, check your results. They are trying to broadcast to you put in a second trial and you'll get another point. All right. So, prepare the space below is code for make a table. So, when they say make a table, they mean make a table like this, with boundary lines that looks all pretty and stuff. Now I'm going to clean up these edges because Cambridge likes it pretty, all dolled up and stuff. Now, over here, I'm going to have my one side and the other side. Here they're going to want their independent variable. The independent variable is going to be over here, and the dependent variable is going to be over here. All right? My independent variable was my concentration, my percentage concentration. I'm going to run out of space, so I'm actually going to erase that. Percentage concentration of triglyceride. Now, stating percentage concentration of triglyceride means that I don't need to write /%. I could if I just wrote concentration of triglyceride, write /%. And now I have a unit over here. And my dependent variable was my time to reach endpoint. It's exactly right here. To calculate time to reach endpoint. To reach end point. And I calculated it in seconds, /seconds. Now in America, we put parentheses. But in merry old England, they put slash. So we're going to do it English style because, well, that's what they do in the question paper later. And if England does it, we're going to do it. Because whatever they do, we'll do. And if anything they can do, we can do better. Because America. All right? So, percentage concentration. I'll just rewrite percentage. Because I like that better. It fills up my space more nice. It fills up my space nicely. All right? Now, I had 4 concentrations. So I had 5, 4, 3, 2, and M. Just because. Now, remember, they did say that if the time taken to reach endpoint for any one concentration is longer than 5 minutes, record more than 300. Using the color M may help you recognize the endpoint. Now, because I don't necessarily need to include M here, I might as well just erase this because it's just way too much space. So I'm just going to take that stuff off. All right. So 5, 4, 3, 2. Now I'm going to use my raw data over here I'm going to use my data that I processed over here for 20, 42, 92, and 114. 20. We'll cut this part out. All right. We'll just make a hard cut here, and we'll cut in starting now. All right. So 20 seconds, because that was our raw data from here. 42 seconds, because that was our raw data from here. 92 seconds, because that was our raw data from here. And 114 seconds, because that was our raw data from here. Notice how I'm not putting in units, because I have my units up here. All this is underlined. And I have units. Everything is here. No units in my table. Whole numbers only in my table. Independent variable and dependent variable over here. I don't need to write IV and DV. I'm okay. Now, for that fifth point that I told you about before, what I can do, if I had done a second trial, now I'm going to say for a moment that let's all go to make-believe land and say that I had done a second trial. I need to use ruled lines to do this table. Alright, that looks ugly. Make yours prettier than mine. Make yours much prettier than mine. If my YouTube demographics are to be believed, most of you are young enough to care about the appearances of your graphs and tables, because you're in school and stuff. So care about your prettiness of your graphs. All right. So let's erase that one. Make it pretty looking. This is why you work in pencil for graphs and tables and stuff, so that it stays pretty. Percentage, concentration of triglycerides. Oh boy, messed that up. All right. Trial 1, trial 2, (20, 42, 92, 114. All right, back to make-believe land now. Let's say that I did this trial again, and I got 22, 40, oops.
We'll cut this out.
Yeah, we'll cut this out.
After cut, 3, 2, 1.
Okay, 95. And 117, because I feel like it. All right. Now, this is make-believe land. I did not actually do a second trial. You would. You would do a second trial. You would do a second trial. Okay. So, that would be my fifth point for doing it again, like it tells you to, from these hints. These are hints. These are hints. Okay. All right. Now, as far as calculating the activity of lipase goes, here's how you do that. For the 5% concentration of triglycerides, it took 20 seconds. Done. Ta-da! So if we do the math on that, it is lipase. The activity of lipase is it was complete in 20 seconds. So the activity of lipase was complete in 20 seconds. Therefore, the lipase activity is completion, therefore, one completion per 20 seconds. So if it's 1 per 20 seconds, that is the activity of lipase. One activity per 20 seconds. That's the activity of lipase. So that's what we do. So 1 over 20 is, in a decimal, s to the negative 1 power, magic of math. No, I should actually do the math. All right. So let's see. 1/100th. Gosh, it's been a while since I've done fractions. Let's cut here.
Okay.